Okay, so today we move to the chapter 5 connecting particles, question 4. So before question 4, we'll talk about a little bit about the pulley. Right, so in these chapters, chapters, we always consider a pulley is in the smooth situation. A pulley is a wheel that can turn, right? So normally we will connect two particles through a pulley, right? Okay, so when these two particles connect to by a wire or in extensible or a solid wire, okay, so this particle will connect under a system, right? If this item in a system, so if you, let's say you release this item to move, right? So this item will move in, the lighter one will go up, the heavier one will go down, right? So, but the acceleration, the magnitude is the same. The magnitude are same, right? But in a different direction. So when you analyze, I will suggest you separate them to two sides, right? Two individual particles, okay? But they have the same A, so that the positive direction will be the direction of movement. Okay, you follow the direction of movement as a positive direction. Okay, so in this system, the pulley system, okay, we can let's say this is A and second one is B, so you can take the A out, okay, you may separate them to two scenario, okay, so A and B, right? So because they are connected by a cable or wire, so here you should assume that, maybe you assume tension first. This is the tension first, so the tension go up, okay, so another one also tension go up, they have the same T because the same cable, right? Okay, so here will be the mg, so this m belong to A, another m will be belong to B. Okay, so we follow the direction or analyze, so you have a T go up, you have a A go up, and another side you have the A go down, right? So you analyze the pulley by this way, okay? So once you have separate these two items, you were able to form the net force equation for both items. Let me remove the left hand side first. Okay. So for A, you were able to form a net force equation by using you may using mg, this m belong to A, okay, so T is opposite direction to the direction of movement is equal to ma, okay. So for B, okay, T will be the direction of movement, T minus mg opposite direction of movement, okay, is equal to mba, right? So you can form two net force equation, then you solve it simultaneously, you should able to get the answer for T and A, okay? So it's a similar thing to the previous part, separate them to two sides, okay, then you can analyze, right? Okay, so for this pulley, let's say the simple pulley system, two side, one big one small. So if you take this you cut the particle out, it will be remain the cable, right? Remain the cable, so you know that this is T and this is T, right? So the total force that act on the pulley will be equal to 2T, right? right? So there is a question that asks you, okay, the resultant force that act on the pulley is how much, okay, or the reaction force of the tension on the pulley is how much? The answer is 2T, right? So the 2T add on the pulley, so the pulley will add 2T on the opposite side also. So this is the Newton's law. Okay, so this is the principle. But if there are the situation that let's say this is the table system, right? The pulley is here, and T is here, and T is here. So in this situation, you if you want to find the reaction force on the pulley, so this is at the center here, right? So you need to do what? You need to use the you need to square both T and square root, right? So you need to find the resultant, right? Okay, so this is another part. So for this question, the resultant will be equal to T square plus T square, right? So square root of 2T square, right? So a little bit different. So add on the center, and you need to find the resultant. Okay, so there are the situation that are in different angle, right? So this one is 90 degrees. Then if a different angle, same things, you need to find the resultant. Okay, then you were able to find the force that add on the pulley. Okay. Right, now we proceed to question 4. Okay, question 4, a box of mass 3 kg is placed on the table. Okay, the coefficient of friction between the box and the table is 0.5. A string is attached to the box and pass over a smooth pulley. Okay, at an edge of the table, the part of the string between the box and the pulley is horizontal after passing over a pulley. Okay, the string hangs vertically with another end attached to the ball to a ball of mass 2 kg. The system is released from rest. Okay. Okay, so before we start to analyze this question, you may need to draw a diagram for this. This diagram may be something like that. If you have a table, okay, for question 4, your table like that, pulley is at the edge, this is a pulley, and you hang an item, let's say an item here. Okay, so this is T, and you go up. Okay, you have another item here. Okay, so so you have a logically lah, this one if you release of rest, the thing will drop down, it won't go up, right? Unless you have some force on top, then the item will go up. If not, then the item will drop down, right? So the acceleration is here. The item of 2 kg 20 Newton here. Okay, and for this box, they will move in this direction. Okay, and you have mg 30 Newton. Okay, and don't forget the question mentioned find the tension in the string. The pulley is smooth, but the table is not smooth. You have a friction here, F. Okay, then you have a normal contact force here. Okay, this is the system, the pulley system. So in order to find the tension in the string, so you will need to form at least 2 equations to solve it. Okay, so so we need to, because you want to find the friction for the tension in the string, so you need to consider the block and the ball separately. Okay, so this is a diagram. I jump to next part. Okay, so for the block, okay, what you have? Okay, you take the block out. Friction is this side. Okay, you have a tension in this side, mg here. Okay, so if you want to form a net force equation in the movement direction, so we move in this direction A. Okay, so you can form what for the block? So T minus, okay, remember follow the direction of movement as a positive direction. So T minus F is equal to 3A, right? Don't forget in the friction F equal to mu R. So T minus mu R, mu is 0.5 times R is 30, right? So 15, 3A. So you have the first equation. Okay, so this one for first part. So now we move to the ball. For the ball, here is a T. Okay, so here is 20. No other forces. Then this item will move in this direction. So direction of movement we assume is a positive. So 20 minus T is equal to 2A. Right, so you have the second equation. Okay, by using the simultaneous solving methods, okay, you should able to find T, the tension at the end is 18 Newton by solving these two equations. Okay, so you should get 18 Newton, right? Can, so this one for part A. For part B, the ball is initially 8 cm below the tabletop. Okay, the ball hits the ground after 1.2 seconds. The box has not reached the pulley. Find the height of the table. Okay. Okay, from part 1, once you get the T equal to 18, you may continue to find the A, right? So if you continue to find the A, the acceleration from part A, so you should get A equal to 1. Okay, and the system is released from rest. Initial velocity 0, A equal to 1, and after 1.2 seconds, the item hits on the ground. So when the system is in the tension, so the A will be same for the full system. So you can use the constant acceleration equation, S equal to ut plus half at squared. Right, so S will be equal to half, okay, half times 1 times 1.2 square. Okay, so you should get S equal to 0.72, right? So this 0.72 is the distance that travel from rest to the ground, right? But the question is asking you the height of the table. So the height you need to have 0.72 plus the distance from the table originally, right? So the total is how much? Right, so the total is 0.8 meter. Okay, the table 0.8 meter. Right, if you change to cm will be xcm, right? Zero 0.8 meter. Okay, this is for question 4. Right, so we once they're done, we proceed to question 5. Okay, for question 5, a crane of mass 500 kg rests on a slope and is attached to a rope that pass over a smooth pulley. The slope is inclined to 20 degrees to the horizontal. The coefficient of friction between the slope and the crane is 0.1. What happens to the crane when a force of 2000 Newton is applied to the vertical part of the slope? Okay, same things. You need to have form a diagram first. Let's say we draw a diagram. Okay, here's 20. Okay, you have a frictional force F. Okay, and you have 2000 Newton pull out. Normal contact force R and mg here. Right. Okay, so this is your diagram. Right. So for this question, to the apply to the vertical slope. Okay, so this is the diagram that you need to do. Okay, so we may need to find the uh, frictional force first. Okay, so F equal to mu r and is equal to 0.1 times 5,000 cos 20. Right. So by this way you should able to find F equal to 470 Newton. 470 Newton. Okay. So once you have this force, okay. So once you have this force, you may direct find the component of the find the net force equation for the component that down the slope and the resultant to up the slope. Okay. Okay. How we proceed? Okay. So we will use the first one. Here first. Okay. 5,000. Sine 20 is equal to 1710 Newton. Okay, and so up the slope, you have the resultant up the slope will be 2000 minus 470, the frictional force, minus 1710. This is the force to bring the item down. Okay, so you will get negative 180 Newton. Right, negative 180 Newton. Right. So what happened for this? Okay, so you have a negative Newton. This means then the acceleration is equal to negative, right? So means the item won't slide up. Okay, the item will slide up. So on the other hand, what happened? Okay, if the item won't slide up, okay, so most probably the item will slide down, right? Okay, if the item slide down, okay, we need to change the diagram to this way. Okay, so we need to change the diagram to in this way. So if the R still here, here still 5,000. Okay, don't forget this one, the 2,000 still go up. Okay, if the item wouldn't slide up, mean the item maybe slide down. Okay, if the item slide down, okay, so your fractional force will be this direction. Okay, at the beginning we consider the item slide up. Now, because once we calculate, we find out that the item won't slide up, most probably will slide down. So I change the direction of friction. Okay,